Let's now look at the function in top k. So what this does is it outputs whether the targets are in top k predictions. And again, here the note is that the predictions do not have to be normalized. That is the probabilist. That is the values in each of the rows could add up to uh, maybe more than one if they are normalized. That's what I'm thinking. If we look at an example, let's create a target, and this target will be representative of the actual class constant, and this will be representative of the actual class for that particular problem we are trying to solve. We have class 0 and then we have class 2. These are the true class true class labels for each sample. Each sample means each row. Now let's look at the predicted values, tf.constant, and these are going to be values that we have uh, so for each row. Now the very first case we have the values 0.1 and 0.1 comma 0.8. So let's change one thing. Okay, no, that should be fine. Sorry. 0.1, 0.8, 0.1, and then the next one we have 0.3, 0.2, and 0.5. Following that, we have 0.9, 0.05, and 0.05. Okay, so what we have here is this. These are the predicted probabilities for batch sample 1, and likewise we would have the predicted probabilities for the rest of these rows. So the second one, this would be for the sample 2, this would be for the sample 3, and this 0 is referring to this first row, this 2 is referring to the second row, and this last 0 is referring to the last row. Now if we calculate the top, so let's put that in Z as we have been doing in this particular series of videos. tf.math.in top underscore k, we input the target, which is the target variable, and then we input the predicted values, and then we specify the value of k. So if we say top k is equal to 1, what we are saying is that whatever values we have here, the largest value would be the class to which uh, would be the class that is predicted. So in this case, let's say if this represents the first column index 0 represents class 0, this represents class 1, and this represents class 2. The third column represents class 2. When we say k is equal to 0, what we are saying is that in this particular values that we have, predicted probabilities that we have, uh, the very first value, that is largest probability that we have, if we sort these numbers, just for sake of explanation, if we sort these numbers, what we'll have is 0.8, 0.1, and we'll have 0.1. So now the top one in this case is going to be 0.8, and before we look at what that is, what we do know is that this 0.1 is coming from the second column. So it belongs to the class, it belongs to the class 1, right? So if we say this is class 0, this is class 1, then this is class 2, so that belongs to class 1. And accordingly, this second one then would be could be class 0, and then the last one would be the class 0, 1, and 2. This would be the class 2. So what we are saying is, when we sort these, the top value here is what, 0.8, and that value, the predicted label then for that probability is 1. However, the actual value for that class, label for that class is 0, and so that's not a match, and that's a false. Uh, the value that we have, the for the class 0, that's the true label. If you look at it from the other's perspective, if you have a true label 0, we see that the true label is not the top one probability in that particular row, and therefore we would get a value that is false. So if we type print z dot numpy, we would get a value that is false for the first one, because this is false, because the top value does not belong to class 0, it belongs to class 1. Likewise, if we likewise, if we look at the second row, in the second row, let's look at what the values we have. The first value is 0.5, next value is 0.3, and the last value is 0.2. And if we look at the classes now, 0.5 belongs to which class? In this case, it belongs to class 01, it belongs to class 2, right? Because this is the class, this is the first column is class 0, second column is class 1, third column is class 2. Next, 0.3, that belongs to class 0, and this 0.2 is in the middle column, that belongs to class number 1. And so again, the question we ask is uh, the what is the class for the predicted value? Is it the top one? So in this case, it is top one. So the top one probability does belong to class 2, and that is also the true class, and so we get a true value. Likewise, if we look at the last case, in the last case what we have is, let's remove these. In the last case what we have is the probability of 9, 0.9, followed by 0.05, followed by 0.05. Now if we look at the class for the 0.9, it is class 0. 0.5, this could be class 1 and this could be class 2. Now the class 2. Now the top value, the top probability does belong to class 2 in prediction, or class 0 in prediction, and therefore the predicted value here does match the true value, and therefore we do get a true in the output. Now what we can do is we can try to change the value of k. If we now try and change the value of k such that k is equal to 2, let's see what happens. In this case now, the very first, if we take this first case again, let's copy these probabilities and paste them here. And accordingly, we can put the real classes that are there. So this is the true class. Again, this is the probability, this is the true class, and this is the probability value. So or instead of saying true, just say class, and this is the probability. What we are saying is that in 0.8 again is the highest probability for that sample, which belongs to class 1. Now, because we specified k is equal to 2, what we are saying is that, hey, even if the probability is not the top, the highest probability, even if it belongs, even if it is the among the top 2 highest probabilities, we are still good. And so in this case, the 0.1 and 0.8, they are the top 2 probabilities, and therefore the class for, therefore we could say that so therefore we can say that the class 0 is among the top 2 classes predicted, and so it would match the true class, and therefore we would get true here in the output. If this one is slightly confusing, we could change that and put there on another number there. Let's put a 0.2 there, and then try and put 0.7 there. So now when we run this, what we get in the output is a different value. So let's see what that value is. I'm going to copy this and paste it right here. So what we have now is the highest probability is 0.7, and then we have the following probability is 0.2 in this case, right? So the if had we said that the first value were true, well, if it was true, the true class was true, then we would get a true, because we would get a true. Let's see. The first case we are yeah, right. So this one we would get a true here, because the even though 0.2 is not the highest predicted probability, it is among the top two highest predicted probabilities, and therefore we can so in the output we are comparing that the predicted class 2 is equal to the actual class 2. However, if we replace this 2 by 0, now run this. Now what has happened is the for class 0, the probability that we have is 0.1. It is not among the top two predicted highest probabilities. It is not among the top highest two probabilities, which is 0.7 and 0.2, and therefore the predicted class becomes 0, which does not predicted class becomes 0 in this case. Sorry, my mistake. Predicted class becomes 1 because 0.7 is the highest probability, or it could be 2 because it's among the top two, but not 0. And therefore, we get a false. In a briefly, in a very short, what we are trying to do here is for each row, we are looking at the probability values. And in general, the higher the values, highest value, we assign that row to that particular class. And sometimes highest value can be relaxed a little bit, and we can say instead of highest, let's look at top two values or top three values. And if our probabilities are in that, then we can say that that's a correct prediction. So that was it for this video. I hope in this video you got some intuition on how to use the in top k method in TensorFlow math. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.